This is question number 13, section B, secondary chemistry, paper 2025. So in this reaction, in this question, you are asked to write any 4 reactions which are given here. So put a heading here. You do not need to write the complete heading. You just write ethyne with HBr. So what to do? There are 2 ways to write the answer. The one way is to write in a way that draw the ethyne molecule, and this is ethyne, carbon-carbon triple bond, 2 carbon atoms are there, and add HBr. So in this way, what will you do? Both of the carbon atoms are equivalent here, so carbon and bromine and hydrogen can be added to anywhere, whether this carbon or this carbon. So I have shown here that hydrogen is added to here, so it becomes H2, and here the Br is added here. So in the next step, what can you do? The same compound, but remember that now the carbon atoms are not equivalent because it has 1 hydrogen and 1 bromine while it has 2 hydrogen atoms. So here Markovnikov's rule is applied, and hydrogen goes to the carbon atom where more hydrogen are there, while negative species goes to the carbon atom where less hydrogen are there. So bromine comes on the same carbon atom where another bromine was there. So in this way, the product that is obtained here is 1,1-dibromoethane. There is no gap in the name. And here I have made a mistake that there should be a double bond, not a triple bond. Okay. So this compound is 1-bromoethene. 1-bromoethene. And another way of writing this reaction is you can write it like this, because coming here, most probably the paper would be taken on e-sheet. So there would be little space given there. So the limited space is given, so you have to manage your answer in that space. So you can write this. The first product is this, and then add another HBr and draw the product H3C CH and Br on both the carbon atoms. Oh, sorry, Br on the same carbon atom, both the Br on the same carbon atom. So in this way, you can manage this in one line. So this is also a way to write such chemical reaction which occurs in 2 steps. Now the next reaction is ethanol with acidified K2Cr2O7. So put another heading, ethanol with acidified K2Cr2O7. So you can write acidified K2Cr2O7 in this way as well, or you may use sulfuric acid here. So now see what happens. It also occurs in 2 steps because it does not stop in its intermediate step. So what's this? There is an ethanol molecule. So what happened when this ethanol reacts with K2Cr2O7? So it liberates oxygen gas. It is an oxidizing agent, and you can write the reagent here, Cr2O7. In bracket, you can write acidified, or you can write H plus. I will show it in the next step. So in first step, what happens? The first step of oxidation occurs and it forms an aldehyde. So ethanol is formed, ethanol, and it was ethanol. And in the next step, as this reaction does not stop here, another oxidation step occurs, K2Cr2O7 slash hydrogen. You can write it like this, or you may write H2SO4 as well. So the final product would be ethanoic acid. Ethanoic acid is the final product. Ethanoic acid is the IUPAC name, and its common name is acetic acid. So this is the second reaction. The third reaction is the Grignard reagent with carbon dioxide, and they have not mentioned which Grignard reagent. So don't worry, you can use the smallest one. So the next reaction is Grignard reagent with carbon dioxide. So this reaction produces carboxylic acid, and depending on the alkyl group on Grignard reagent. So if the alkyl group is methyl, so in case of methyl group, acetic acid is formed. So see what happens in first step. Again, you can show it, reagent on the arrow. So it produces CH3, and this is the C of the carbon dioxide, and another oxygen is there where magnesium iodide is associated. Then in the next step, it is worked up with water with dilute acid. So what happens? It produces CH3, C double bond, and it becomes H. So it becomes ethanoic acid. And water is enough here. Don't make it acidic. So water forms, hydrogen of the water goes to the oxygen atom, and it becomes ethanoic acid while it forms magnesium hydroxyiodide. So in this way, we have made ethanoic acid. The next reaction is reaction of ethane diol with HiO4, that is periodic acid. The name of this compound is periodic acid. So the reaction heading is ethanediol, and better to write ethane 1,2-diol. Ethane 1,2-diol with periodic acid, and the formula of periodic acid is HiO4. So what happens? See, first draw the ethane 1-diol, ethane 1,2-diol. So what is ethane 1,2-diol? See, there is CH2 and CH2. Both the carbon atom, both atoms have OH group. So it is ethane 1-diol, ethane 1,2-diol. And what happens when periodic acid reacts? It cleaves the molecule and produces 2 moles of methanol, form aldehyde. So 2 moles of methanol are formed. You can write 2 here. And along with the product is iodic acid. So actually it oxidizes the alcohol groups on ethane diol, and itself it is reduced. So this is an oxidation reaction. And now the last reaction is reaction of ethanol with alcohol. So ethanol with alcohol, and they have not mentioned the name of the alcohol. So ethanol with alcohol. So in this case, you can write any of the alcohol, methanol, propanol, ethanol, propanol, any of the alcohol you can write here. So see what happens. This is ethanol. And we are doing this reaction with ethanol, CH3, CH2OH. And this is ethanol. So now see what happens. So the product is hemiacetal. See what happens. First, the alcohol act as a nucleophile, and it reacts on the electrophilic carbon on the aldehyde. So in this way, hydrogen remain there, and this oxygen comes from the alcohol, while the hydrogen of the alcohol ultimately transfer to the oxygen atom. So in this way, a compound is formed where the carbon has on one side ether linkage, on another side alcohol linkage, and this molecule is called hemiacetal. Hemiacetal. But I don't know why they have given this question in the paper because this reaction is no longer the part of the intermediate chemistry syllabus. Although it was in the previous book, the old book of chemistry has such a reaction, but not this book.